Test coverage is a metric that some teams use to evaluate the health and quality of their code. It's typically evaluated as a percentage, and what it is the amount of your application code that is executed when your test suite runs. The theory being the higher the number or amount of your application code that's run, you're more likely to catch issues. If something changes in your code, a test will catch it. This is not a talk on test coverage, but is on the underlying underpinnings in the Ruby language that allow tools to evaluate things like test coverage. Okay. Ruby's coverage module has 4 different modes with different questions you can ask it. So we're going to talk about each of those modes today. We're going to talk about lines coverage, one-shot lines. We'll then talk about methods coverage, and we'll wrap up with a conversation on branches coverage. So we have our set. Let's start the show. As promised, we're going to start by talking about lines coverage. And for lines coverage, we're going to help out the band's guitarist, or more specifically, their guitar techs. We're getting ready to go on tour, and we need a lot of equipment. And one of the things that we need a lot of are guitar strings. Guitars get restrung before every show, but also sometimes they just break during a show when you're playing. And we need to make sure we have enough strings so that the guitars can maintain playable throughout the show. And if you're not familiar with how playing the guitar works, here's a dramatically hyperbolic and also kind of wrong model of how that works. When you pluck a guitar string, it first checks to make sure that it actually can be played. And if it can, then the tension is released a little bit. It becomes a little looser, and you play the note and you move on to the next one. But the problem is when you can't play it, which is partially a function of how much tension's on the line. So we can predict that, right? We know how much the tension decrements, and we can know like after X number of plucks on the string, it's going to break. But also it just kind of happens sometimes. So we can't accurately and like deterministically model when this is going to happen in our system, right? And when a guitar string breaks, it marks itself as broken, and it plays a sound that is not the sound you wanted to play. So we're trying to figure out how many strings we need for our concert tour here. And what we're going to do is we're just going to guess for the first couple shows, right? And if we need to run out to a local store to grab some, we will. But we're going to use those first couple shows to get our bearings right and figure out how many we might need and use that to place an order for the rest of the tour. And so we might think that we could put a logging statement in this method, right? We might just put a put statement in there, instrument this method in some way to give us some feedback that we have gotten to this point in the code so we can keep track of how many times it happens. But we have one more constraint on our system right now, and that is, like I mentioned, the band's just about to go on tour. They've finished up all their rehearsals, and they have their instruments just the way that they want them. So we can't touch any of this code at all. It doesn't matter how trivial the change is, this code is frozen, okay? And we need to figure out how many times we're breaking strings. So what we're going to do is we're going to play the first couple shows. And like I said, we're just going to guess. We're going to hope that we got it right. And if we don't, we'll figure it out from there. And so we're going to play those couple shows. And when we do, we're going to do so with the help of Ruby's coverage module. Coverage ships with the standard library in Ruby, but if you want to use it, you need to require it. And you start coverage with the aptly named start method. So you call start, and here we're going to start coverage in lines mode. And what lines mode tells us is how many times each line is executed while coverage is running. We're going to use that to figure out how many times we're breaking strings. We're then going to load up our script that plays the first 10 shows of the tour. And we can see what we get back from coverage by calling the result method. Okay. And so what we get after playing the first 10 shows of the tour is we get a giant hash with a bunch of information. But let's dig into just one element in this hash and talk through what all these values represent. The hash is keyed on a string that represents the name of a file executed while coverage is running, the value of which is a hash keyed on the mode of coverage. We specifically asked coverage to start in lines mode, so thankfully it gave us lines coverage back. And the value of that inner hash is an array of mostly numbers. And what these numbers tell us are how many times each line is executed in that file. Right? So order and position in this array matters. Right? So this first element tells us how many times line 1 was executed. And in this feedback, lines 1 through 6 were each executed a single time. Line 7 is a special case. Line 7 is nil, which doesn't mean it wasn't run. It'd be 0 in that case. What coverage is telling us here is not to worry about line 7. It's doing us a favor, and it's also doing itself a favor, quite frankly. So let's look at what line 7 is. Go back to our source code in our string.rb file, and we see it's an empty line. All right. So I suppose there's a fun philosophical discussion you could have here on what it means to have evaluated or not to have evaluated an empty line. But coverage just sort of sidesteps that because, like, you want to use it to make decisions and answer sort of questions, some specific questions. So for things like empty lines or end statements or comments, coverage is going to tell you, don't worry about it. It doesn't matter if this was run or not. We don't even know how to necessarily evaluate that, right? And so back to our problem at hand, we're trying to figure out how many times we've broken strings over the first 10 shows, right? So we can get the lines coverage result back for our string file. And we're going to say that when a string marks itself as broken by setting the broken instance variable, that's when a string is considered broken, okay? And that's on line 54 in our file. So to figure out how many times line 54 was run over the first 10 shows of the tour, we're going to ask for index 53 in the array because arrays in Ruby are 0 indexed. So the 0th index represents line 1. So if we want line 54, we need to ask for index 53. And what we see is we get back that we broke 16 strings over the first 10 shows. And what we get there is a not statistically significant, but hopefully good enough for a rock and roll show, guess for how many strings we can order for the rest of the tour. And we got to that value thanks to lines coverage from Ruby, which will tell you how many times each line was executed while coverage was running. That's not all that coverage can do for us. I promise there are 4 modes. We're going to talk about each of them. Let's talk about our second one here, one-shot lines. And for one-shot lines, we're going to help the band get ready for one very specific show. They've been booked to play a festival. And that's great news for the band. They get introduced to an audience that otherwise maybe wouldn't come to see them. They play a shorter set, so technically less work. And the money's pretty good. So it's a good deal overall, but it does have its share of constraints that they don't usually have, right? Playing at a festival means that there are bands that play before and after them, and they need to make sure that they maintain a tight schedule so they get on and off the stage on time to not ruin everyone else's set times, right? There's also only so much space, physical room to store all the stuff that goes on the stage. So the crew is trying to evaluate ways that they can pare down the amount of stuff that they have to set up on stage, both so it will be quicker to get on and off stage and also just to eliminate the amount of storage space they need. And one of the things that the band has a lot of on stage are synthesizers. Multiple members of the band play the synthesizer. In fact, at any given time or throughout the course of a show, every member of the band plays the synthesizer, even if it's not your primary instrument. If it is your primary instrument, you're probably playing more than one at the same time. And like, I wasn't lying when I said every member of the band plays the synthesizer. Here's a picture of the drummer. Notice they're not in front of a drum kit. Right now they're playing a synthesizer. So there are tons of these instruments just like all about the stage, right? And the crew is trying to think of like, if we can get away with like a few fewer synthesizers, that saves us so much time that we have to like plug things in and get things working and set up. So let's try to find some way for this one show, we can just like only have the synthesizers we absolutely need, okay? And before we get to that point, we're going to sort of talk about how synthesizers work so that we can understand how to interact with it and answer that question. Synthesizers, very nicely named, they synthesize different sounds, right? So you spin different knobs and turn different dials and push different buttons. The sound that the instrument makes changes drastically. And you can save these sort of like positions as presets called patches. So they can be quickly recalled when you're playing the instrument, right? The name patch comes from the original synthesizers actually used electrical circuit connections with jumper cables or patch cables that you would connect together, like an instrument you can see in the back there, and some of them still do operate under that. And when you're playing the synthesizer, it's very important that you set the right patch on the instrument before playing the note that you want to play. Because if you play the right note with the wrong patch, musically, it sounds correct. But to the person just expecting to hear the song, it could sound radically different than what you actually wanted it to sound like. Okay. And now each synthesizer implements its patch memory differently. Let's look at one particular instrument the band has on stage. It's an older synthesizer. My screen sharing has stopped. I will get that set up again. Sorry. This is fun.
Somebody play music instrument. There we go.
Okay, great. So different synthesizers implement their patch memory differently. This one particular instrument is an older instrument, and it has 4 areas of patch memory. It just has 4 physical buttons on the instrument you can press to recall the patch memory. And so it implements accessing its patch memory with a case statement. Right? And how that works is when you press each of the buttons, it accesses a different place in memory, loads that in as the current patch, and makes the sound that comes out from that patch. And so we're trying to figure out for this one show, how many of these patches on all of these instruments across the entire stage do we actually even use, right? And we're going to take advantage of the fact that the band has to prepare for this show, because remember, they're playing a shorter set time. So they're playing different songs, or they're perhaps not playing songs they would regularly play. And so we're going to utilize that rehearsal to figure out which of these instruments we're even using, or sorry, which of these patches we're even using, right? So when the band sets up for a rehearsal for the festival, we're going to set up the stage exactly like we would for a regular show, where every synthesizer is going to get every patch that it regularly would, and we'll have them play the show. Sorry, rehearse the festival. And we're going to, as you might guess, do so with the help of Ruby's coverage module. This time, we're going to start coverage in one-shot lines mode. What one-shot lines will tell you is not how many times a particular line of code was run, but just if it was run. And that's sufficient for our needs here today, because it doesn't matter how many times we used a patch. It just matters that we did, right? Whether we need it one time or 7,000 times throughout the course of the show, we still need to make sure it's accessible on stage, okay? And one-shot lines will answer that for us. So we'll have the band rehearse the festival set list, and we'll see what we get back. What we get looks really similar to what we saw with lines coverage. But let's once again just look at one element in this hash and talk through the return structure here. We get back a hash that is once again keyed on a string that represents the name of a file executed while coverage is running, the value of which is another hash keyed on the mode of coverage. And then we get back in that innermost hash as a value, an array of numbers. And what these numbers are the actual line numbers in the source code that were run. So the order isn't necessarily important here. This is just telling us these are the lines that were run while coverage was running. And so for our purposes here, when we ask for which lines of our patch memory run, we just get a whole bunch of numbers that represent lines in our source code. And so we have to go back to our source code, and we're trying to figure out which of these patches we were using. So we're going to keep track of the 4 line numbers inside the case statement and look to see if any of these numbers came up, and that will tell us if we were using these patches. Right? So we're going to build an incredibly complicated and wonderful user interface to get that information back. Right? So we're just going to ask which of those 4 lines are being, do any of those 4 lines come up in the output for one-shot lines? And what we get back is not incredibly helpful, right? It turns out we probably almost definitely need this instrument, right? We're using 3/4 of its patch memory. So like we can't really consolidate there. But if we perform the same analysis on every other synthesizer on stage, we might find one that perhaps we're only using one of the patches. And then we can see if maybe we can have a facsimile or a stand-in sound put on that prior instrument for this one show, have the band use that instrument for that one patch. And that will allow us to not even need to have that synthesizer on stage at all, reducing the amount of setup time and teardown time, and allowing the band to still get on stage on time, play the full show, have it sound exactly the way it should, and not screw up the schedule for everyone else on the bill. And we did so with the thanks of one-shot lines mode of coverage, which will tell you if a particular line was executed. And we used that to determine if we were using certain patches on our synthesizer. We're halfway through. Our next mode of coverage, we'll be talking about methods coverage. And for methods coverage, we're going to be helping out the lighting team. As the tour has gone on, they have themselves a bit of a problem. There's a spotlight on the lead singer, and sometimes during the show, it just goes out, and not when it's supposed to. That's a problem for a couple of different reasons, right? Mostly that the lighting team has a lot of pride in their work and they want to put on the best show possible for the audience. But also, let's just say the lead singer is a bit of a perfectionist. So they're well incentivized to get to the root of this problem. But similar to the band's stance on synthesizers, they have a bit of a challenge, which is that there are a lot of lights on stage. Like a ton of them. Like the band contracts out with lighting firms and special effects companies to design lights that didn't even exist before just for their concerts. So we have a very real world, incredibly complex debugging problem with a lot of variables at play. And one of the theories is that perhaps we just don't have enough power to sustain all of the lights on stage that we need. And yes, we have a concert rider and a contract with the venue where they signed off and agreed that they have the sufficient power to light all these lights. And I don't want to say that venues lie, but what I will say is that mistakes can happen. And so whether that's the problem or not, we need to try to figure out some way to make this easier to get our hands around what's happening with our spotlight here. And so let's talk about how lighting at a concert works. The lighting team, just like the band, are performers, except they're mostly not on stage and almost entirely get none of the credit. But for every single note of every single song for the entire show, they're responsible for making sure that the visual aesthetic of the stage looks exactly the way it should, right? By turning certain lights on, turning certain lights off, and not only turning them on and off, making sure that they're facing the right direction and they have the right color on them and they're doing the right thing in terms of like strobing or just being a solid light or fading in and out or whatever it is that the light does, right? So the lighting team is incredibly focused for each beat of every single song to make sure that the stage looks exactly the way it should so that the band can focus on sounding good and the lighting team will make them look good. And now, as I mentioned, there are a lot of different kinds of lights that the lighting team may use, but whether they're using a projector or a can light or a moving light or our problematic spotlight, in our system, all of those different kinds of lights respond to the trigger method. The implementation details of what those lights do when you call the trigger method to turn them on or off is radically different, but they all respond to the same method signature. They all have the same public API. And so we're going to use that to our advantage and take a similar tact that we took for which patches we're using to try to figure out which lights we're even using, right? Because as the tour's gone on, the band has started playing different songs, and that means they have cut certain songs out. And there may be songs that we're no longer playing where that was the only song that they needed a certain light for it. And maybe we don't even need it anymore. And if we can unplug it, that might help alleviate our power concern. And even if not, there are that many fewer lights that they have to troubleshoot to figure out what the actual problem is. So the next time that the crew is in town and they set up the stage, have the band perform, and then tear everything down, load it into the trucks and vans and move on to the next city, we are, you guessed it, going to perform this operation with the help of Ruby's coverage module. This time we're going to start coverage with the methods mode. And what methods will tell you is how many times each method was executed. And that's all that we need here, right? We're going to look at which of these trigger methods for all these different lights get called. Right? We don't care if the light calling the trigger method goes 2 lines in and then raises an exception. We don't care if it runs 50 lines of a giant method. It doesn't matter. We don't need to keep track of line numbers. All we care about is that this method was called, right? And that's sufficient evidence to us that we are using this light. Okay. So we'll have the band play the next show under coverage, and we'll see what we get back from our methods coverage. What we get looks reasonably different than what we've seen thus far. So let's take the same approach of looking at one element in this hash and just explain what this data is. The hash is keyed on a string that represents the name of a file executed while coverage is running, the value of which is another hash keyed on the mode of coverage being returned, the value of which is yet another hash keyed on a bunch of information identifying the method in the source code file. And the value of that innermost hash is the count for the number of times that method was executed while coverage is running. Now, I skipped over a bunch of stuff, and I promise I'm not going to go through without explaining it. So let's zoom in on this innermost hash and talk about what all these data elements represent. We already talked about the value on the right-hand side, which is the count for the number of times that this method was executed while coverage is running. And now going left to right to explain all the values in the key, this first element is the name of the class. Now remember, the outermost hash is the name of the file, and that might be, and in most cases is likely to be, redundant. However, in Ruby, you can have a file that has 0 or more classes in it. So this is helping to identify exactly which class we're talking about in that source file. The symbol is the name of the method in the source code. And then we get back 4 numbers. And what these numbers tell us are the starting line number, the starting column number, the ending line number, and the ending column number for where we can find this method definition in our source code file. In our example here, we don't actually need these numbers, but we get them back, so we have them. But for our case, all we care about is finding which lights we used throughout the course of the show by calling the trigger method. Or more importantly, which lights we didn't use. And so we can see here that we have a projector that for every single show, we plug in, make sure it works, get it all ready to go, and then never use it. Right? So now the next time the band rolls into town, we can make a little change to our setup process, right? We can just delete this line. We don't need the projector anymore. And then hopefully by making that change, we have enough power in our venue to support the lights that we do actually use. And if not, we have reduced our complexity of what could possibly be the problem by that much more. And we did so thanks to methods coverage, which told us how many times each method is executed when coverage is running. And we use that to figure out which lights we're using throughout the course of a show. We have one more song together here tonight. We're going to talk about branches coverage. For branches coverage, we're going to get the band ready for the last show of the tour. They happen to be playing in a town where one of their friends, who's also in another band, is going to be in town at the same time. And so they've invited him on stage and said, hey, pick out a song you want to play and we'll play it and have some fun. And so he gets back to them with the song that he wants to play. And it's one of their songs, but it's not a song that they've been playing on this tour. So in the shows leading up to it, during sound check, they've been practicing the song because, they don't want to play it for the first time on stage with a bunch of people and look like fools. And so they know what they're going to play. And, in the late afternoon, they amble onto the stage for sound check, which for a band on tour might as well be, early in the morning. And, there's much stretching and getting ready to go. And they play the song exactly how they would want to play it during the show. But something's just sounding off. Something's wrong. And they can't quite figure out what it is. And now they're a relatively tech-savvy band, and they know what's going on. So they turn to the crew and they go, hey, crew, you've used coverage to answer a couple questions throughout this tour and helped us out. Can you figure out what's going on with this song? And the crew says yes, because that's their job, to say yes and then figure out how to make it a reality. Well, they've got a bit of a problem, right? Previously, we've used coverage to answer very specific questions about our code that we knew coverage could handle. Right now, the question is, this is broken, can you fix it? And we have no idea if coverage can actually help us here. And so we're going to go on a bit of a fishing expedition. And we're just going to tell coverage, like, look, just, I don't know, give me everything you got. Right. So we can start coverage by giving it a special method signature. We can pass it the all symbol. And that still tells coverage, run every mode, just give me the maximum amount of output possible. Right. So we'll start coverage with all the modes running. We'll have the band rehearse the song again in sound check, and we'll see what we get back. And unsurprisingly, what we get back is a ton of information. But what I want you to take from this is hopefully some appreciation for the data structure we've been talking about thus far, right? I've been painstakingly going through and explaining how the hash is keyed on a name of a file that has an inner hash that is keyed on the mode of coverage. That sounded redundant because I've said every time we've started coverage in lines mode and we get lines mode back. And like, yes, of course we do. But we've been very explicitly running coverage with only one mode and very explicitly telling it which mode to run. But you can run multiple modes of coverage at the same time. And whether you're running one mode of coverage or all of them, the data structure that's returned from the coverage module is the same. So you can traverse the structure in a consistent, understood pattern. So now it's time to figure out what's actually going on here. So let's start by just seeing which modes of coverage were run. And we get back lines mode, methods mode, and branches mode. Now, I promised you that there were 4 modes of coverage, and in fact, we spent an entire section talking about one-shot lines to help the band prepare for a festival, and we asked coverage to run every mode of coverage, so what is happening here? And the answer is that there's an implementation detail in the C code for how the coverage module is actually written such that lines mode and one-shot lines mode can't run at the same time. If you try to do it, it's going to raise an exception and tell you, you got to try again. You can't do it. And so rather than running coverage in all modes, immediately raising an exception and erroring out, what the coverage module does instead is it says, I'm going to run lines mode over one-shot lines. And the reason for that is because lines mode can tell you the same thing that one-shot lines does. Right? Lines mode can tell you if a line of code was executed. It can also tell you more information. Right? It can tell you how many times. So when you run all modes of coverage, coverage is going to run lines mode over one-shot lines and then run all of the other modes as well. That's enough procrastinating. It's time to actually figure out if we can solve this problem for the band. And so let's just, ask coverage some questions. And it turns out that we're running every line in the song. So nothing really there necessarily. And if we're running every line of code, it stands to reason that we're calling every method, and that's true. And then we ask it about its branches coverage, and we get back a 0, which might be a problem. It might be totally fine, but we haven't talked about branches coverage yet. So let's one last time reminisce and discuss what kind of data structure gets returned when you ask for coverage, specifically for branches coverage. We get back a hash that's keyed on a string that represents the name of a file executed while coverage is running, the value of which is another hash keyed on the mode of coverage, the value of which is another hash, the keys of which are each conditional within that file, the values of which are one more hash that are all keys on the different branches within that conditional, within that file that are executed while coverage is running. Let's zoom in on one of these branches to explain all of the data that's in here. As you might have guessed, the value on the right-hand side is the count for the number of times that this branch of this conditional was run while coverage is running. Then going left to right, the first thing we get is a symbol representing the type of branch that coverage is identified. So this is the first part of an if-else statement, and coverage identifies that by calling it the then part, which isn't wrong, but in Ruby, if you're writing an if test, you're not necessarily going to write if, then, else. So you need to kind of take a leap of faith of understanding what that means. The first number that we have here is a unique identifier. In branches code, in branches coverage mode, every branch and conditional gets a auto-incrementing unique identifier, and that's what this number is. And the next 4 numbers are the same numbers we got back from methods mode, which is the starting line number, the starting column number, the ending line number, and the ending column number for where we can find this branch in the source code. And we're actually going to use that information to help us out here, because where I mentioned like, well, we wouldn't type out then when we're writing an if test. So maybe I don't even know where to find this thing if I wanted to guess. But also notice that this entire branch starts and ends on the same line. And in fact, the entire conditional starts and ends on the same line because it's a ternary statement, which is even more esoteric. So even if you were willing to take the leap of faith that you knew where the then part was, maybe you just need a refresher for which part of a ternary statement that represents. And so we're going to use the actual column numbers to go, oh, 10 is never returned while we're playing the song. And now we have an even harder problem, which is to figure out if that's actually an issue. It could be totally fine. Right? So let's take a step back and talk about what this code is actually doing. And what it's doing is setting up a vocal effect on the lead singer's microphone. And when we start the song, we tell it, hey, we've got a couple verses and a couple choruses and an outro. And we pass in the number to the choruses that does a number of things, but of interest here is it's used to set up how much of the effect should be on the microphone. And for each of the choruses, it's supposed to wax and wane. So it's supposed to sound different. And the issue is with the numbers we've passed in, neither 0 nor 1 pass both of the conditionals, right? They're neither positive and even at the same time. And so there's our issue. We found an actual bug in our system thanks to this, right? Because we were expecting it to wax and wane, but it's only waning. And so we can solve that, right? We can make a change here. It's sort of an off by 1 error. We can pass in different numbers, and then one of them will pass the if test and one of them won't. And therefore, we'll be doing the modulation of the effect that we expect. So we commit this change. We ask the band to rehearse one more time under coverage, and we can see that we hit both sides of the conditional. After doing that, the song sounds the way it's supposed to. And the band confidently can go up on stage, invite their friend up for the last show of the tour, play the song, and no one's the wiser in the audience that they had all of these problems figuring out what they need to do for this one song. And we're able to solve that thanks to branches coverage, which will tell you how many times each branch of each conditional is run. And that was particularly helpful in this case because remember, we first asked lines coverage, like, hey, is there any code path in here that we're not executing? And it said, no, you're running every line. You're cool. And that is correct. But there was one line of code that had multiple code paths where we weren't using one of those code paths in the form of a ternary statement. And it turns out that was a problem here. It could have been a total non-issue, but in this case, we were expecting to use each part of that. And by digging into branches coverage mode, we were able to go one level of granularity deeper and identify something that wasn't getting called. So what have we learned today? Ruby's coverage module has 4 different modes that will answer 4 different questions for you. We first talked about lines mode, which will tell you how many times each line was executed. We then talked about one-shot lines, which won't tell you how many times a line was executed, but will just tell you if it was executed. If that's all you care about, then running one-shot lines over lines coverage is a bit more performant, so you can get some benefits there. We also talked about methods coverage that would tell you how many times each method was executed. And we wrapped up with a conversation on branches coverage, which is how many times each branch in each branch of each conditional was run. So we've talked for about a half an hour on Ruby's coverage module and what it provides for you. And now I'm going to tell you that it's very unlikely, but possible, that you will actually interact with Ruby's coverage module directly. However, there are a handful of tools that do use it. And now you have a better understanding of how they use the coverage module and can tweak those tools to better meet your needs. I started talking about test coverage at the beginning of this talk. If you are looking to evaluate your test coverage, there are a lot of tools out there. One of the more popular ones in Ruby is SimpleCov. SimpleCov uses Ruby's coverage module. By default, it runs in lines mode, but you can pass it an option to have it run in branches mode. So you can get feedback not only on how much of your actual lines of code are run when your tests are run, but you can also find out specifically for different branches which are run. And that might be helpful if you have ternary statements, because maybe you don't have test coverage for one path in a ternary statement that lines coverage won't tell you about, what branches coverage will. There's also a tool called CoverBand, which is meant to run in production, and it uses coverage module to evaluate your code on actual production. The main use case I've seen for using CoverBand is for identifying dead code, which is code that's part of your application that isn't being used anymore. And if you're looking to use CoverBand to answer that question, you can set a CoverBand up to run in one-shot lines mode. And that's particularly important because it'll answer all the questions you need. But also remember, CoverBand is running in production. And I said that one-shot lines is a bit more performant than lines mode. So anything we can eke out to minimize the overhead to users in our overall application can be beneficial. And both of those tools use Ruby's coverage module to help us out. If you're interested in getting a copy of these slides, if you want a link to a repository that has all of the code examples in here, if you'd like a narrative refresher on what Ruby's coverage module is, you can get that at kevinjmurphy.com/coverage. Also on Twitter, welcome to connect there and answer questions and chat with folks. I can also answer questions after this. But before we get to questions, I first want to say thank you. I hope you enjoyed the show. But I also particularly want to say thank you to the organizers of this event. Organizing any sort of meetup is largely a thankless job that has a non-zero amount of work. And it can be even more difficult to try to bring folks together now that we're not meeting in person. And it's really, it can be very hard. And I really appreciate all the organizers that are doing the best they can to continue to facilitate the Ruby community in their relative groups. And so if we can just take a moment to give a virtual round of applause for Richard and Andrew here for organizing here today. Thank you both very much.
That's very kind. That was an awesome talk. Thank you so much, Kevin Murphy. Really appreciate that. Open the floor up for questions. I know my interest is piqued. I have a couple, but I don't want to jump the line. John, you have one, please. Did you have a question, John?
Sorry, no, I was just congratulating Kevin on the talk. It was a great talk.
Yeah, it was awesome. Makes me want to know what kind of instruments he plays, if he plays any. Jason, how about you? You have a question?
Shit, I got to unmute. So hi, that was great talk, Kevin. That was really great.
Thanks.
Deep dive. I didn't know all that. Just you said it at the very end there, of course, about Simple Cub, and then you said, it's like right in the last 5 minutes, you said that Simple Cub by default runs in lines mode. And I went to look at my Simple Cub that I have installed on this thing, and I don't know why. Maybe I don't know how I set it up or why this is the case, but it does seem to show me in the interface average hits per line. So it must somehow be in my settings to figure that out, because it does show me the number of times it runs on that line, as far as I can tell.
Yep. So that's what lines mode will tell you, and that's why it uses that over one-shot lines to give you that average.
Yeah, I see what you're saying. Oh, I see what you're saying. Right, the other mode would not do that.
Yep. And it's also, quite frankly, an artifact of history. Coverage used to ship with one mode, and it was lines mode. That was the mode. And then they've progressively enhanced the module to add these different modes in.
Cool.
So if you start coverage without giving it a mode to run, it's going to run lines mode.
Right. Yeah, no, it's cool. I was just looking to see which way I had my Simple Cub is configured. That was great talk. The only thing I was thinking was like, just on the matter of like code complexity, I wonder if anyone thinks about examining the brand. Like if on the one side you are looking for code that you have missed from code coverage, on the other side you might be looking for code that you're running hundreds of times like in your code coverage, and you like go, oh, because I've done that. I'm just a coming queen. Like I go, oh, my test runs that 4,000 times, and that's too many times. So I know I'm over covering. It's just an interesting thing to think about. Anyway, that was my thoughts off the top of my head. Great talking.
Also want to mention Dimitri is one of the organizers. Also Trace is joining. This is my first evening participating as a host. I love this meetup, so it's really nice to be able to do it. I want to apologize to everyone for the beginning of the meetup. We had that little bit of wasn't frictionless with. I didn't realize I could mute the gentleman who was kind of acting up. But anyway, so we got here, and I wanted to ask a couple of questions. I don't see other hands up. I'm pretty new to coverage, so these questions might seem kind of basic. Kevin, I'd love to hear, like, what are the best practices? I mean, what my takeaways are from your talk are, you can definitely look for dead code. You can definitely find things that maybe are getting executed too much. You can confirm your own understanding of your code. You can do these efficiencies, these optimizations that you gave us the examples of, like with lighting and instruments. But a couple of things that come to mind being so new to this. When you are using this, what are the best practices? Because clearly you can't get the best data unless you're in production. There's overhead with that. So I'm just a little naive on what the options are here. I guess you mentioned Simple Cov is basically for test coverage, and cover band would be something you use in production. Would you mind elaborating a little more, kind of drilling into some of those like best practices?
Sure. So I guess this may sound overly simplistic, but and this also may be like more like wide ranging, but make sure you're using the tool for a reason, right? Are you actually going to do something with it, right? Like I've worked with, companies that are like, oh yeah, we measure test coverage. It's like, great. Like, what does that tell you afterwards? Right. And there's like, I don't know, it gives us a number, right? It's like, oh, cool. So you're just like wasting CPU cycles, right? Because like they don't use it for evaluating if they should add more test coverage, or if they should make sure they have enough test coverage, or if they have too much test coverage. So first of all, again, maybe a somewhat level 0 point, but like make sure there's a reason to use it as opposed to like, ooh, shiny new thing, right? I'd also rely on the abstractions built on top of Ruby's coverage module. That's why I reference them like cover band and simple cov. That's why I said you're probably unlikely, though it's still possible and it's available for you, to use Ruby's coverage module itself. The purpose of this talk was to draw some attention to how it works to then better inform how to use those tools. And also, quite frankly, just because I didn't really know about it beforehand. So I just thought it was kind of neat to dig into what this thing is and how you actually evaluate things like test coverage. Specifically for test coverage, I guess sort of the flip side of making sure you use it for a reason is I would caution being too dogmatic about the use of it, right? So like, sure, 100% test coverage sounds great, but there's a lot of overhead with that, and it's not necessarily practical, and you might not be able to make a business case for maintaining that, right? So like at a Rails app, if you just Rails new, and you're going to get action cable, and if you're not using Hotwire and Stimulus, and you're not using any sort of any of the action cable stuff, you have an initializer in your Rails app. And that's going to ding your coverage level, right? Because you're never going to hit those lines of code because you never actually run action cable. And also just insert how action cable works in tests, but maybe this is a poor example. But anyway, and like that may be a signal to you of like, oh, maybe I should go out of my way to like turn action cable off because I'm not actually using it. Or you could just not care about it, right? Because it's part of the framework, and like maybe you'll need it eventually. And like, we're not going to write tests for a thing we're not using, but we don't need to go out of our way to get rid of it either. So I know, some teams have systems in place, and there's some automated systems that will make sure that coverage doesn't dip below a certain number. And that number is always somewhat like fanciful and kind of made up, right? Because like, is 75% a good number? I don't know. What about 80? That sounds about 5 better, but is it really? I don't know. Right. And that's not really a satisfying answer, at least for me, it's not. But like, unfortunately, there's no silver bullets, and like, there's no like just like definitive like, oh, if you do this, then you've done enough. So I think a lot of it is just understanding how your team's going to use the tool, what they're going to do with it, and make sure that it's solving an actual problem and meeting a certain need, and then using that to inform how you write your code and how you maintain your code to make sure that it is giving you the comfort, safety, and stability to ship code, make changes, and be confident that like this is going to be lead to a good outcome when this is rolled out in production. Is that helpful, Richard? Does that get to some of what you're looking for?
Yes, extremely helpful. I really appreciate that. You know, the example you did with the tertiary operator and, you know, identifying the, you know, the problem with the test data that prevented that particular branch from being tested. Is it always, you know, are some of the, like the simple cov and, or, you know, make that any easier, or is that just, you know, you just got to do that work?
So by default, if you run simple cov and you had a test that exercised that method, and let's say you only ran it for the first chorus, line coverage is going to tell us you hit every line of code, right? It's going to tell you you executed that ternary statement.
Right.
That's correct. But unless you have, but if you run branches mode, it's going to tell you like, yes, you did execute this, but you only ran a part of it. And then you can determine, hey, perhaps I have a gap in my coverage and I should write a second test that exercises the second part of that ternary statement. Or maybe I don't need it, and then I don't need a ternary statement. I just always return whatever the other number was that was being tested. Right? Sort of like going back to like the answer isn't always more tests. It can also be giving you information about like, hey, you never test this thing, and also you never use it, so you can just get rid of it. And it's less likely that that's the case. The answer is almost always you don't, just not testing it. But it's certainly possible.
Very good. Very good. Who else has a question? Thank you. Who else would like to ask Kevin some questions?
I'd be curious if anyone on the call is using this presently or something like it. Like, does anyone have this problem? And if so, you know, when's the last time you talked about it and how are you presently solving it?
I can jump in. I actually am wanting to use simple cov, and the reason I'm don't currently have it set up in our application is that between our unit tests and our integration tests, we have good coverage, but each one independently doesn't. And I was having issues trying to use simple cov's like merge results functionality to kind of get both. But in the past, and with other programming languages and stuff I've used coverage a lot just to help kind of like make sure that I'm covering the cases that I feel like I need. And particularly with like branch coverage, I think that's always the classic case where it's like, you know, did you actually write tests or did you get coverage for functionality that's there? And I think with particularly tricky cases, or if you have like a high cyclomatic complexity or something like that, it can be useful to make sure that your test coverage is testing what you want. So I was actually coming to this talk to kind of help understand my context of it in a Ruby environment. I've done a lot of coverage work in Java, but it's very different in Ruby, which is kind of fun.
Yeah. Simple cov does ship with like a XUnit formatter, like a JUnit formatter, if you're familiar with that. So you can pipe that into your tools. But yeah, the merge tool is something I haven't used before, but I'm aware that people have had interesting challenges with it, but I haven't had the pleasure to need to use it either nicely or in anger in the past.
We had pretty much similar issue at my last job. Like we had 100% coverage, at least according to the simple cop. Don't throw any potatoes at me. I've inherited that stuff before I started. It has its ups and downs. The biggest up would be once you have it, it's not such a big of a deal to maintain it. But the problem is, it's the biggest way to, it's easy to get full coverage with an unit test, but then all your kind of acceptance tests, you don't really know unless you are trying to kind of merge the results of the runs. But then having an excessive coverage, you would run into build times. One of the reasons we had to maintain a insanely huge coverage, we had a crazy policies for paybacks to our customers for downtime. It was in like realms of like tens of thousands of dollars per hour of a downtime. So we wanted to maintain as much less defectability as possible. But then again, took us 16 parallel nodes on Travis CI for an hour and a half just to get one build.
Is
Yep.
that in the run time or the code coverage time? Because of the code.
Just like entire, like our code coverage was built into a CI, so it would run a code coverage. We would run a unit test first. They're fast, collect all the code coverage. If it's below 100% for us, could be any threshold pretty much, the whole suite would just fail. So like, whoops, gotta fix that before we continue. But then after that, we would run the full acceptance test coverage and then collect that. That build would take an hour and a half. But currently I'm in Java world, GCP, no tests at all. Perfect.
I was gonna chime in about your question about the simple cov. I've used simple cov forever, it seems like. I just heard of cover band tonight. I'm already in love. I just looked it up. It looks great. I want to get rid of all my dead code. The technical things you guys were talking about, the simple cov. Oh, like yeah, like the default files that ship with Rails, like Action Cable, like simple cov has a thing. It's just add filter, and you just take it right out, and you're just messing with the numbers because you're God, right? And you can redefine 100%. So that's kind of all we're letting you know. It's like, oh, you can just redefine 100% by saying that file's excluded, and that's fine if it's not your file, right? So like that's my opinionated opinion. And then what was the other thing you were discussing? Oh, I forgot. Come back to me. What was the other thing you were discussing? I forget it.
The last question, I think people were responding to the question I asked Jason around, all right, who's using it? What problem does it solve for you? If you're not using it, when's the last time you had a conversation about this problem that might indicate that you might?
I remember the last thing I was going to say. I never heard of the merge stuff. I heard of you talking about the merge problems. I never heard it. I looked it up what it is. And the reason I never heard of it is because my coverage folder is just in my git ignore forever. And so I never have that problem because I don't put the coverage results into git. I just look at them and then move on with my life. That was the other thing I was going to say.
Yeah, I was trying to hook it up to our CI and like a GitHub action or something to report out, which is pretty common. And the challenge was that we run unit tests and integration tests in two separate command line commands. And so I guess theoretically we could like report them out both separately, but I wanted them merged so that we have a better idea. And part of I think I guess the higher level problem that we're trying to solve is my current company, there's me and one other developer, and there's a pretty wide code surface. And so using code coverage as a proxy metric for like our tests are covering most of the use cases of our application. And so if I change something and the test pass, I should feel confident that like it can go to production without breaking something. And so code coverage at least can kind of help give some objective measure that like our test coverage actually covers most of our application paths.
Cool.
I apologize if I missed this, but because I had to join an hour late, unfortunately. But I'm curious, Kevin, if there was any discussion of like how much coverage is the right amount of coverage, and is this tool gonna gamify too much test coverage?
Yeah. So I personally don't subscribe that there's any one golden number, right? everything in life's a trade-off. All things have costs and benefits, and you've got to weigh that out, right? We started talking about, oh yeah, if we have 100% test coverage, then we're never going to have a problem ever again, right? And that's not necessarily true, because at the very least, we have the problem of we need to maintain 100% test coverage, and that's work, right? Tests our code too. We need to maintain that. We need to refactor it. We need to make sure it's stable to updates and upgrades. And this is entirely not a conversation where I'm telling you don't test anything, as much as it may sound like it perhaps is leading to that. But we need to make sure that there's value for developers and ultimately the business, that all these tests are carrying their weight, right? And so I don't think any of that as a like blanket statement can find like, well, I mean, yeah, so 100% is bad, but like 90 is probably good, right? Like we all can just agree that like 90% is like, it's most of it. And like, is that better than 85%? I mean, probably, at least mathematically, but I can't tell you on an app to app basis, like how much better that is or what that's worth to the business to actually make a case that like, yeah, no, we should definitely increase from 85 to 90%. None of which is an actually satisfying or like definitive answer, but like, that's honestly my perspective on that.
I hope the business isn't telling you exactly how much test coverage you can have.
No, but ultimately, like, hopefully we're doing things in some sort of light to make sure that there's a reason we're doing it, right? And yes, I would also bristle at any sort of conversation like that. But hopefully, at least internally, we're thinking about like, oh, we're doing this, and we're doing this because it has value. And how much value is a difficult question to answer. It also depends on what sort of norms or heuristics the organization has, right? So, if downtime is incredibly expensive to you, and contractually so, and coverage can give you more confidence that you're going to have less likelihood there'll be downtime, then there's a definite value proposition there, right? But I can't say definitively if you instead maintained 95% test coverage that it's going to cost you X number of dollars. Like, it might be totally fine. Like, sorry.
It ties in with some. Oh, go ahead.
I'd say +1 to having bugs always will be there. Your users will always find a way to use a product you never thought about and run into all kinds of problems.
Trace, did you have something you wanted to add on to that?
I forget. It'll come back.
Okay.
Wherever Jason's was. Jason, are you talking? I see your mouth moving.
What do you think's the right amount of coverage, Trace?
Sometimes I'm going to be a little controversial here, but I've heard sometimes numbers as low as 70%.
Sure.
So this is the thought that I did have, is it kind of goes back to some of our previous discussions, or I'm not sure if we've had them here. I know we had Cindy Metz on, and I wasn't there for that, but she likes to talk about her Omega messes, and there are just maybe things that have been in the system forever. And these may be the things, Jason, that you're filtering out, even if it's your code, because it's just, it's abandoned. I'll hope you enter here, but hasn't been a problem for years, and the developer wrote it left. And, so that you can focus your optimization of your test coverage around the things that are, really causing problems. Like you're going to run a whole bunch of, trades in production, give away all your crypto. But I don't know where I heard that number. I thought, oh, that sounds good. And there was I don't know if we ever posted it. When I was at Thought, one of my colleagues, Gus Manjo, had ideated a blog post called "Too Much Dry Leads to Deserts." It's and what I loved in the time that I was there, the code was like pristine, and it was a joy to work in this beautifully clean house. It was like a museum, but it was so optimized for that sometimes it didn't make business sense for how beautiful some code was that didn't need to be. So it's the same sort of kind of trade-off around coverage. And if I saw something where I felt like I was being rewarded, or I set up an OKR that was, well, if it was 100% test coverage and I got 70% of that OKR, then maybe I'm okay. But 90, 95 sounds great. Bobber, like in your situation, of course, you're going to want to test all the things.
Yeah.
It feels like such a judgment call, the cost of adding more test coverage or the cost of making the code beautiful or what, however you want to, there's not that many objective measures in my experience that really answer that question succinctly, except for just, your subjective experience.
Trace, I don't know if this is where it got lodged in your head, and I don't know if you're familiar with Ernesto Tag Worker or Ombu Labs or Fast Ruby, but they're a consultancy and they do a lot of Rails upgrades, and they will not work with companies that don't have a particular bar of test coverage as starting point, and I think their metric is 70%. So when you said 70%, I was immediately like, oh, was that from Ernesto?
I don't think so, but
I also don't think he
remember
invented the number
specifically.
70, but
That